Hello. This is very interesting video. I am demonstrating machine learning and the deep learning model comparisons. This is the machine learning model I created. Both are in Excel here, but the front end is Excel only. But the back end, everything is done by the Python. As you can see, this is the only VBA code. Nothing else is there. So it imports this linear regression, multi-factor linear regression Python code, and then it calls this main function within that. So everything is in Python. We are just using that Python from Excel. This is a game changer. So we can, in this approach, definitely whatever the power of Python, we can utilize that within the Excel. So very interesting and very powerful. It makes Excel a very powerful tool with this approach. So I'm doing in that way. So this is the machine learning model. The here what we are doing is I am using the loan predictions, eligible loan amount. Sorry, to calculate the eligible loan amount based on this training data. This is a training set of data which is very small, not big, but as much as data that we have more and more, so the model will train itself in a better way and we can get the better results. And here I am using alpha as 0.01 and total iterations as 600. The iterations also we need to optimize. If the iterations are low or if iterations are too high, it takes more time, more processing, and more CPU power and everything comes here. So there is another way. Instead of specifying the iterations, we can also set the maximum iterations in the code and then see the descent values. When the descent or the error goes below point, say 0.005, then we can say it as a converged. That I have done it in a single factor linear regression model. In my next video, I'll do the demonstration for that. In this machine learning model, I'm using mean squared error method as a loss function, and then gradient descent for the convergence. Um, um, that's the one gradient descent I'm using to for the convergence or for the optimization algorithm, and then mean squared error to calculate the loss. So now I am using this 5 point this row so that we can check. It's not ideal to use the same data here. We can do something different, but I'm using it just to make sure the results are what we are getting that can be compared to the actual values. So this is the values. So now I'll click on calculate eligible loan amount and at 600 iterations. Now you can see it's going on. These are all the beta values. Beta values are set initially to 1 and the value of b is equal to 1. That's the linear regression, like y hat is equal to b plus w1 x1 w2 x2 and so on, right? So these are the w values, and b value initially set to 1. So later on it will keep on changing based on the. Now we can see it is predicted as 73.11. So for these 600 iterations, if the iterations goes down also, the convergence may not happen. So I think this 600 is a ideal number. So if we go for 650, but still I think it will come and stop at this point only. So I'll make run once again. So it's 70 now, 73. You can see it won't go too much high because the convergence point is coming at 73 here. So this is the machine learning model, and this is the deep learning model that I used as one hidden layer, one input and one output layer. Hidden layer has 8 neurons. We will change this number of neurons and see how the results works. And the output layer has 1 neuron. So the advantages of using this particular deep learning model is that if these if we use this as a linear regression, and if the values are not the linear regression, if it is a polynomial, it's not a straight line, then definitely we cannot expect the better results. It will not fit properly. So in that case, this artificial neural networks definitely fits better and gives the better results. That's one advantage. And now this is the model, and we can see I'm using the linear activation, and then here also gradient descent and mean squared error method. This has 8 neurons in the hidden layer. I'm using 60 epochs, and now let's run it and see what the values results that we get. So unlike the machine learning model, because this uses Python and TensorFlow in the background. So I'm just putting directly this one. See, now you can see this. This has given 80 and this has given 73. So maybe in the if we instead of a linear, we use a ReLU, we get much better results. Or otherwise, in the linear itself, if we use Adams Adams optimization, definitely it improves the results in the Adams is better than the gradient descent. Now I changed the optimization to Adam. Now let's see. You can see this 73.9. That is the Adam. And if we go further, and since there is no negative values in the Y, this is the prediction amount Y. So we can very well use the ReLU. ReLU is also better to use in this scenario. Now I clicked on calculate eligible loan amount. Now let's see the results. Okay. So it is much better, very close to the actual value in the by with these combinations, ReLU, Adams, and mean squared error. So this is the comparison. So I just wanted to reiterate it again. This is not entirely a VBA is not entirely used. Very little. That is only to call the Python. We are using VBA. Otherwise, everything is written inside the Python, and it calls and exchanges the data from Excel from the Python and Excel to Python and Python to Excel. So that's the one. So it's always much better using deep learning, artificial neural networks for predictive analysis. I have created one more model that is a single feature that that's a single feature, only one feature, entirely in VBA. For one feature, yes, it's okay. With the factors standardization, we can get results. But when it goes to the multiple features and all this, definitely it will take huge amount of time. It's not like it's not possible to build entirely, but it takes huge amount of coding, and performance also it goes very bad. No, not as good as using the Python. Thank you for watching.